Hello and welcome, my name is Reinhard Partmann. In this video we will talk about Horizon Physical storage design aimed for applications. Okay, let's get started. So, like in all storage related areas around you, performance is a key factor. Also capacity, we also have talked about this in other videos. But now we are actually talking about how we can match the use cases to the ways we can provide applications to our end users. So we have a couple of options there. So we have a list, so we can install an individual software into a desktop, we can install the software in a master image, we can provide it with ThinApp, we can provide it with app volumes or remote desktop session hosts. Every method has its advantage, disadvantages, flexibility and manageability. Those are, let's say, our pillars where we have to measure our designs against too, right? And always aim for the best solution or for the most flexible solution you can provide. Well, if you look at the picture, this is a classical Windows desktop from the view when we are going to want to install applications. So we have our operating system layer, we have our data, and we have our applications. We can install it manually, so this is very flexible, but from the management aspect, not so much, right? So you would have to have access to the machine, the user can't work during your installation and stuff like that. And it results in non-standard machines. So you install on machine A software package A, on machine B software package B, and so on and so forth. And then you have, well, different packages everywhere, different versions, patching becomes a nightmare and stuff like that. We have a master image for our pools when we install software there. All pool machines have the same set of software, the same version and everything, right? When we do our patching, we patch our master image, roll out the new version of the master, and all the desktops have again the same new version of the software we are going to provide. We have a good standardization. I wouldn't say it's highly inefficient, but we can do better. But when we have no other option of having master images and providing applications like that, there is often the possibility that we are ending up with more than one master image. So you also have to take into account, don't let them to spread too much, because you don't want to have, let's say, 10 master images you have to maintain, because then you are going to be very inflexible and you're going to lose your standards, right? So this is actually what we want to battle. To having too many master images, we want a small, neat, clean, fast master image, and to that master image we want to attach our applications based on the use case. If you look at the slide now, we have our traditional desktop, and then we have the possibility of using app volumes. What we are actually doing there is, we have a small, neat master image, and we attach so-called app stacks, and those app stacks contain our applications. Let's say we have an app stack for our core application and an app stack for department A, for example. Department B will get the same core app stack, but a different departmental app stack. Maybe research and development, they have different tools as finance, obviously, so they get a different departmental app stack. The third disk we are seeing there is the writable volume, and this is a per user disk, so we can store user related data and applications there, and they will move from desktop to desktop, so that the user has always the same user experience. So let's dive a little bit deeper into app volumes. As you have already seen, with app volumes we have a lot of benefits. We can attach more than one app stack to a virtual machine so that the user gets many applications or the application he really needs. He can have a writable volume to store data and install application if he is allowed to, and we can manage application lifecycle. We have dynamic application delivery and stuff like that. It's very cost effective, it's very flexible. One last point which is very, very important, please do always have a backup of your app stacks, right? You don't want to create all the app stacks again if you have a data corruption or data loss. In the next slide we are a little bit talking about the whole infrastructure surrounding app volumes. What do we have? We have the app volume manager, we have our virtual machines, we have data store where our app stacks are located. And basically what we are doing is that the app volumes manager is a nice web interface. There we can configure which user gets what app stack, or we can do this on a group basis. So when a user is logged on, the agent sends an information to the app volumes manager back. This is being evaluated and the related app stacks are being attached to the virtual machine of our user. So for what do we need to accommodate now? Well, this is easy. Let's have a look at the picture. You need to accommodate all the app stacks and all the writable volumes, right? On the other hand, you have a couple of virtual machines, the app volumes managers. They also need to be stored. So this all goes into your design because they all need capacity, they all produce IOPS. App stacks, they only produce read IOs because data is only read from those files. Writable volumes, they produce read and write IOs. So your storage need to accommodate for this performance-wise, also capacity-wise. Another possibility of providing applications to our end users in virtual desktops is an application called ThinApp. ThinApp is an application containerization tool provided by VMware. It has a lot of features. You can run legacy applications, you can even run different versions of applications on the same desktop. You can deploy those applications very neat and easily out to your desktops and even physical PCs. How are ThinApp packages being deployed? Well, normally in an exe format, or if the application is very big, you have an exe and a .dat file, and there is also the possibility of a so-called installation via MSI, and then you can register the exe with ThinReg so that the extensions of the documents and data files are being correctly bound to the exe files. As you can see also on the slide is how can you distribute it. Distribution is relatively easy. Either you run the exe file from a file server, or you put it on a USB drive, can run it from there and copy it on your laptop or desktop. Infrastructure-wise, because applications need to be stored so that we can run them, it's very lean and very small. You have a packaging and publishing environment. You store the data on some kind of a file server, and from there it can be run. So if you store many versions of your applications, you need a little bit more, depending on the size of your application, because I can't tell you how big your applications will be. There are small ones and there are big ones. And if you have many versions, well, it multiplies, right? So you have to accommodate for the space on your file server. When you run it over the network, you also have to take care that the network traffic is available and the bandwidth is there. When we are going to compare that, let's say we compare app volumes and ThinApps, where are the differences? Number one, we can integrate both of them, and the difference basically are, on one side we are attaching virtual disks to a virtual machine. The applications are containerized in these disk files, and ThinApp, well, they are containerized within the ThinApp runtime. These are completely different approaches to provide applications. Well, and the third options we haven't talked about up to now is remote desktop session hosts. Remote desktop session hosts are a very, very good way to provide applications to a lot of users because we can scale them out very easily. So we have a remote desktop session host, we put our applications there, and from there we can publish out our applications. What are the big benefits if you look at that? It's a good consolidation ratio, it's a centralized platform, we can incorporate BOYD because the application runs on our remote desktop session host and is being projected to the client where the user is sitting. We have good access controls and manageability. So, to summarize, we have ThinApp, which is basically application containerization within the ThinApp runtime. It's for physical and for virtual desktops. It's application isolation. We can run it on well, let's say on newer Windows versions where it has been packaged. Sometimes we need to update the ThinApp runtime around it, but that's a very easy way, and then the application will work again. We have app volumes, where we attach our app stacks to our virtual machines, and we have remote desktop session hosts. And at the end of the day, we can incorporate all of these technologies into our solution. And this is a very, very good way, because for different use cases we have different methods, and this is a good way to match and mix our available technologies to the use cases. So you only have to pick and choose and go along with the preferred solution for your application.